Dear students, after seeing a number of problems in friction, let us see one more interesting problem of friction, that is the two blocks are placed on the cart and a force F is applied on the bigger cart M, and it starts moving in rightward direction with certain acceleration. We have to find out what should be the maximum acceleration and minimum acceleration at which these two blocks remains at rest relative to this M, or they will remain rest on the bigger cart M, right? So this is question how to decide, and mu s is coefficient of friction between the blocks and the cart. Here blocks and the cart, the coefficient of friction is mu s. Now we can find out the maximum and minimum acceleration for just drawing the free body diagram. It's very simple to decide, and in very simpler way we will see how to find out the maximum and minimum acceleration in this situation. Now when it is accelerated in rightward direction with maximum acceleration, you will observe this block is at rest, but it will have tendency to move in leftward direction. Why? Because at maximum acceleration you will observe a pseudo force will act on this one in leftward direction, and if we just increase the acceleration from A max, it will start sliding on the leftward direction. So I can say the block is at rest at maximum acceleration, but it has tendency to move in leftward direction. Now in minimum acceleration, I will say at minimum acceleration this block will remain at rest, but it will have tendency to move in rightward direction, and the friction force will act in leftward direction. So let us draw the free body diagram at maximum acceleration. Let us draw the free body diagram, and let us find out what should be A max. Now when we draw the free body diagram for this bigger block, you will observe a pseudo force will act. A pseudo force will act here, that is M A max. I can write M A max, and normal reaction here will act here in upward direction. Its weight is acting in downward direction, mg. Now you will observe tension will act in rightward direction, and since at maximum acceleration this will remain at rest, but it will have tendency to move leftward, so frictional force will act in this one direction. I can write Fs max, is it? Now I can write down at maximum acceleration T plus Fs max. Fs max is equal to mass into A max, and I can say T plus maximum static mu s mg normal reaction. I can say T equal to m A max, or I can simply say T equals to m A max minus mu s mg, is it? This can be written at maximum acceleration. At maximum acceleration, this will be the tension acting. Now when we draw the free body diagram here, the normal reaction here N1 will be acting in this direction. The pseudo force will act in this direction M A max, and now it has tendency to move in leftward direction. This will go up, so frictional force will act in downward direction. That is nothing but mu s time the normal reaction, and normal reaction is M A max. So I can say write M A max, and tension T will act here. So I can write here T equals to mu s M A max. Weight is also acting in downward direction, so another force mg plus mg. Now you will observe with both these tension are same, so equate them. These two are all are equal. So I can say, you can see from this one, A max, if I take on left hand side, I will write down mu s m A max minus m A max is equal to mg minus mg minus mu s mg. Is it clear? I can take this minus sign here. I can write A max is equal to A max I can write, and M is also taken outside. I can write mu s minus 1, and here minus is taken, mg is also taken. I can write 1 plus mu s. Right, I can take minus on this side. A max can be written as m gets cancelled. I can write it is mu s plus 1 g, and when minus sign comes on this side, I can write 1 minus mu s, or I can say 1 plus mu s by 1 minus mu s g is maximum acceleration. And then I can find out the maximum force also. The maximum force can be written as F max, mass into acceleration. M plus 2m is the total mass, and acceleration is nothing but it is equal to 1 plus mu s by 1 minus mu s into g. Is it? Now same way in at minimum acceleration you will observe this Fs max is not acting in rightward direction, but it will act in leftward direction. Here also mu s mg will act in upward. At minimum acceleration this will be at rest, but it will have tendency to move in rightward direction, so frictional force will act in leftward. So just change the sign of mu, plus to minus, minus to plus, I get the minimum acceleration. So directly I can write the minimum acceleration is nothing but it is equal to 1 minus mu s by 1 plus mu s g, and the minimum force can be written as F minimum can be written as m plus 2m 1 minus mu s by 1 plus mu s into g. Is it clear? So this is the situation. I'll take one more example here. Now at one more example for triangular case. This was the rectangular cart, and two blocks was placed on this, and they are moving in rightward direction. So maximum and minimum acceleration I can take 1 plus mu s by, you can remember 1 plus mu s by, since maximum acceleration will more, so plus will be in numerator, 1 plus mu s by 1 minus mu s into g. Is it clear? That maximum acceleration. And minimum, just change the sign of mu s, 1 minus mu s by 1 plus mu s g. And to find out maximum force, minimum force, you take m plus the mass of the two, and then you can decide. Now I will take similar example here. Let us see what happens at the different examples when we find out the value of F max. And now let us see one more example. I'll take, suppose I say this is a cart, right? This is a cart, and right, this has got mass m. Now let us see two blocks are there. Now this is m, this is m, and this is, let us take m, let us take, this is m, sorry, this is smaller m, and let have one more is placed, m also. And we have to find out force F is applied, and this is mu s, proportional static here, mu s. Now again, at this place I can find out the maximum acceleration as equal to A max as 1 plus mu s by 1 minus mu s into g. At this acceleration, the block will remain at rest, and the maximum force will change only. F max can be written as now m plus 2m plus 2m, and then 1 plus mu s, 1 minus mu s into g can be written. Is it? Now when we change this value, let us see one more example. One data. Let us take one more data here. Suppose I change the masses. Let us take, I am changing the masses. This is m, and then this is m1, and let us take, this is m2. Force F is applied. Then what will happen? The A max will be same. If this is mu s, I can say F max will be 1 plus mu s by 1 minus mu s into G. But F max will change now. F max will be equal to m plus mu s m plus m1 plus m2 into G. Is it? That will be the situation. But now when we change the coefficient of friction, then the situation will be different. Now one more situation I will take when you change the friction coefficient. Suppose I take, now let us take one more example of triangular case. There how to find out. Suppose I take, this is a mass m, this is a wedge of mass m, and a block m is placed here, and mu s is coefficient of friction, and here friction is 0, and force F is applied here. Now here also we have to find out what should be the maximum acceleration and minimum acceleration so that this block will remain at rest. Now you will observe here, this angle is theta. I can say this is normal reaction N, and weight will be acting in this direction mg. I can say in this direction theta, and this will be theta. So I can say mg cos theta will act in this direction. In this direction mg sin theta will act. Is it? And now at maximum acceleration this will remain at rest, but this will have tendency to go up. Now the moment it will go up, you will observe it will go up, the frictional force will act in downward direction, that is mu s into normal reaction. Is it? And the pseudo force will be acting here, that I can say m a max. I can say it has two components, this is theta, so this will act in here m a max cos theta, and in this direction m a max sin theta. Is it clear? The forces. Now the normal reaction N can be written as mg cos theta plus max mg cos theta plus m a max sin theta. Can I write normal reaction? Now since this is at rest, so I can also say m a max should be equal to the mg sin theta is acting in down the plane, mg sin theta, plus frictional force will act also in the air. So mu s time normal reaction is nothing but mg cos theta plus mu s time m a max sin theta. Is it? Now I can take this a max together. I can write m a max equals to 1 minus mu s sin theta. When I take on this side, ma max is common, so I can take 1 minus mu s sin theta, and here also I can take mg as common, sin theta plus mu s cos theta. Is it clear? Now I can say the a max is this gets cancelled. I can write it is g sin theta plus mu s cos theta divided by